Hey, welcome to the 22nd lesson on C++. In this lesson, we will study one of the fundamental concepts of OOP, namely, the concept of inheritance. To begin with, let's understand what inheritance is. Inheritance is when you can create two separate classes and then specify that one of the classes will be the parent class, and the other will be the child class. In this case, the parent class can describe common basic functionality, and the child class can inherit all this common functionality and complement it with its own features. Let's explore why this is useful and how it can be implemented. I suggest starting with practical implementation and creating a class right away. Let's name it PC, which will describe various computers. In this class, we will create a couple of fields. For example, we'll have a diagonal field to store the diagonal size of each computer. Additionally, I want to create a field related to the operating system, so I'll name it OS. There could be many characteristics here to describe the entire computer, but for now, let's stick to these two attributes. Next, we'll create a constructor. In this constructor, we'll receive the diagonal and operating system of the computer. Let's immediately adjust this data to the fields in our class. To do this, I'll refer to my fields using the this keyword and assign the parameters I provided. Now I have a basic class that describes computers. Computers come in various forms, such as supercomputers used for massive calculations, quantum computers, laptops, and different types of computers. Each of these computers has its own specific set of characteristics. For example, when talking about quantum computers, there will likely be a unique set of characteristics that only applies to quantum computers and is unnecessary for a regular computer. Here's what we can do: we can describe all computers and characteristics within one class. In this case, we'll have a working program, but the problem is that when I create a laptop, it will have characteristics that it doesn't need at all. It would be much more convenient to describe all standard characteristics present in all computers within one class and then create additional classes, such as computer, supercomputer, quantum computer, etc. These additional classes will inherit the common functionality from the base class, and in these classes, we'll describe additional functionality needed only for specific types of computers. In this way, we'll have a more structured program, with each class responsible for a specific type of computer, while the common base functionality will still be in one unified place. Let's imagine that we have a class describing laptops. So, here I'm writing that we are creating a class called laptop. Right away, I want to specify that this class will inherit all the data from the PC class. To do that, I just need to write a colon here and then specify that we inherit everything from the public class PC. From the PC class, we will inherit all the data that is either in the public or protected access modifier. We cannot inherit anything from private since it is a closed modifier. This means that everything written inside private is accessible only within the PC class. Later, we will work with the protected access modifier and make sure that this data is visible only in this class and in the inherited classes. Now, let's create our own field in the laptop class. This characteristic will be specific to laptops, and let's call it weight. I agree with you that the weight of a computer can be useful not only for laptops but for all computers. However, let's specify that weight is a characteristic that applies only to laptops. Additionally, I will create another constructor here. For this, I write the class name, and in this constructor, I will accept the same parameters as in the previous constructor we recently created. I will also take another parameter, weight. In this constructor, I want to set the values of the two initial parameters as values for my base class, and for weight, we will set the value for the field here. Let's use a pointer to refer to the computer's weight. Now we need to pass the parameters to the parent class. This is done as follows: you write a colon, and then you write that you are referring to the parent constructor, and in this constructor, you pass parameters such as the diagonal and OS. So now, when I create an object based on the laptop class, I will be able to pass all three parameters. Now let's create an object that will be named laptop. We'll call this object Mac. Here, we pass the parameters diagonal, which is 16. Also, I specify the operating system as Mac. Additionally, we'll specify the weight of the laptop, let's say around 1.5 kilograms of course. Now we have created an object based on the child class. In this object, we pass characteristics that are set in the parent class. In general, we have now covered the concept of inheritance. The advantage here is that if I need to add functionality specifically for laptops, I'll add it to this class. And if I need to add some common functionality for all computers, then in that case, I'll add it to my base class. Let's indeed try to write a method here. This method will be called getInfo, and all it will do is display the operating system on the screen. Additionally, we will also display the screen diagonal. Now, we have our method in the parent class, but since we are implementing the concept of inheritance, I can easily access our Mac object and immediately gain access to the getInfo method. We can run this, and upon running, you will see that information about our computer is displayed, such as the operating system and screen diagonal. Also, I want the weight of our computer to be displayed. To do this, we need to override this method in the child class. However, in this method, we will not output the information that was displayed in the base method. Instead, I'll simply call the getInfo method, but only from the parent class. To do this, at the beginning of the method call, I should write in reference to the PC class, and through 2 colons, I call the method I need. In other words, we refer to the parent class and call the getInfo method from it. Let's also add that we will output the weight of the computer. If we run the program now, we will see complete information about the computer. This includes the operating system, screen diagonal, and computer weight. Thus, we have rewritten the functionality of the base method. Now, let's talk about the protected access modifier. This is a modifier that indicates that all the data inside it will be accessible within the class itself and within the inheriting class. Let's now change the access modifier in the PC class to protected, and now I can access these fields from the PC class, as well as additionally from the inheriting class. To do this in the laptop class, we need to access the diagonal field and try to set some value there. I don't need this, so I will simply comment out this line of code to remind you that this is possible. That is, now I can access this data either from the base class or from the inheriting classes. However, if I tried to access this data through an object, an error would occur, as these fields simply won't be there. So, protected allows specifying that data will be accessible only within the class itself and in the derived classes. In principle, this implements the concept of inheritance, where you can create one class to describe the basic functionality and then create additional derived classes that inherit all the basic functionality and complement it with their unique functionality. And with that, our lesson comes to an end. If you enjoyed the lesson, subscribe to the channel to not miss new videos. Until next time.